Hey everyone, let's start with question number 5, Digital Electronics, asked in GATE Examination 2025. In the circuit shown below, the AND gate has propagation delay of 1 nanosecond. The edge-triggered flip-flops have a setup time of 2 nanosecond, a hold time of 0 nanosecond, and a clock to Q delay of 2 nanosecond. The maximum clock frequency in megahertz rounded off to the nearest integer such that there are no setup violation is. Although the solution of this question is very small, but we will first analyze this question because these questions were asked in several exams. So first we will see what are the prerequisite of this question. So first you have to find the number of different paths going from flip-flop 1 to flip-flop 2. We will write this. You have to find different number of paths which is connecting oblique joining two sequential circuits, that is flip-flop 1 and flip-flop 2. So I will redraw the circuit. So if you see, this is flip-flop 1 and this is flip-flop 2. The path joining the flip-flop 1 to flip-flop 2 is, this is the first path which is directly connected. We will say this is path 1, and the second path is this one, which is going from a AND gate. This we will denote as path number 2. Now we have recognized the different paths. Path 1, we will write this directly flip-flop 1 to flip-flop 2, and path 2 is going from flip-flop 2 to an AND gate, which is nothing but a combinational circuit, then going to flip-flop 1. Based on these two paths, we have to calculate the first is T clock should be greater than T clock to Q time plus T setup time plus T combinational circuit minimum time. So this is known as setup time constraint, which should be followed for the proper operation of the complete circuitry. And what is not asked in the question, but you should be known this, by default if you calculate this condition is already satisfied. So the next condition is T clock to Q plus T combinational minimum time should be greater than T hold time. So this is known as hold time constraint. Although this is not asked in the question, but this condition is already satisfied. I will show you in a minute. So now we will come to the solution of this question. Now starting with, we know the path 1, so on putting the values t clock in equation, let's say this is A and this is B. So putting the values of t clock to Q, which is given in the question as, if you see, t clock to Q time is 2 nanosecond, hold time is 0 nanosecond, and setup time is 2 nanosecond. The propagation delay of the AND gate, which is a combinational circuit, is 1 nanosecond. So please remember this. I am writing the values. So t clock 1, I will denote this 1. I am finding for path 1. I am calculating this for path 1. T clock to Q time is 2 nanosecond. Setup time is again 2 nanosecond. And combinational circuit between the path 1 is nothing combinational circuit is. So we will write 0. So t clock 1 time should be greater than 4 nanosecond. Similarly, we will find for path 2, writing the equation and putting the values again. So setup time is again 2 nanosecond. The first is t clock to Q is 2 nanosecond. Setup time is 2 nanosecond. And this time one AND gate, which is a combinational circuit, is having 1 nanosecond. So it comes out to be 5 nanosecond. Now you have to take the intersection of these two, because one t clock is saying that the time should be greater than 4 nanosecond and one is saying the time should be greater than 5 nanosecond. So t clock comes out to be should be greater than 5 nanosecond, this part, for this to be proper operation. So what should be the frequency? The maximum frequency that should be 1/5 nanosecond, which comes out to be 200 megahertz. This should be the maximum frequency for this circuit for proper operation. Now the second part which I wanted to show you, that if we write the numbers for equation number 2, which is clock t and combinational minimum and hold time. So the clock time is 2 nanosecond plus combinational is 1 nanosecond, which should be greater than hold time. Hold time is already 0 nanosecond. This is for path 2, because I have put the combinational circuit as 1 nanosecond, clock to Q as 2 nanosecond. If you put the path 1 also, so you will get 2 plus 0 should be greater than 0. So you can see both the conditions are already satisfied. That's why this question doesn't say for calculating the hold time constraint. But you should be aware of hold time constraint in future. If the question asked what will be the maximum hold time for this to proper operation, so for path 1 it should be 3 nanosecond max, and for path 1 it should be 2 nanosecond. So this is path 2 and this is path 1. So maximum 3 nanosecond, maximum 2 nanosecond. So if we take the intersection of these two, So we will say that t hold time should be max up to 2 nanosecond, because if we again do the intersection 2, 3, so we are saying this can go up to 2, this can go up to 3, so we will take the intersection this 2 nanosecond. Thank you.